Hi students, MCQ 17. During an adiabatic process, the pressure of a gas is found to be proportional to the cube of its absolute temperature. The ratio of Cp by Cv, that is gamma for the gas, has to be determined. This question is very brilliant question, not so easy. Our thinking power should be very high. Okay children, now how to approach this problem? What is the given condition? First I will write, okay? It is an adiabatic process is given and the pressure is found to be proportional to cube of its absolute temperature. So what is given? It is given that the pressure P is directly proportional to T cube. So this is our expression number 1. This is the clue given for us, okay? But actually for adiabatic process, okay, for any adiabatic process, there is some relationship between pressure and temperature, okay. So what is the general expression or relationship between pressure and temperature? T power gamma into pressure P power 1 minus gamma is equal to constant. So this is the equation of state relating temperature and pressure. Understand? So I will write P power 1 minus gamma is equal to T power minus gamma into constant. So T power gamma is on the left hand side. When I take it to the right hand side, it becomes T power minus gamma. Okay. Once again, what is the power of pressure on the left hand side is 1 minus gamma. What will happen if I will change the power from 1 minus gamma to gamma minus 1, okay? So I can write this is P power gamma minus 1, I am shifting, okay? So that here T power gamma, so this is T power gamma into constant, like that it will come. Understand that? Or we can also write that T power gamma is proportional to P power gamma minus 1. So here I can also write it T power gamma is proportional to, or else I will write as it is. So P power gamma minus 1. P power gamma minus 1 is proportional to T power gamma. As it is, I will keep it as expression 2. Okay, now expression 1 is P is proportional to T power 3 and expression 2 is what? P power gamma minus 1 is T proportional to T power gamma. So I will readjust, okay, or P power, so P raised to the power gamma minus 1 divided by gamma minus 1, okay. This must be equal to what? T raised to the power gamma divided by gamma minus 1. So mathematically we can adjust the powers like this. When left hand side is proportional to right hand side, then the powers can be divided by the same entity. So that P raised to the power gamma minus 1 by gamma minus 1 is equal to T raised to the power gamma divided by gamma minus 1. Understand that? So I can write this or P is now proportional to, okay, so this must be proportional to T raised to the power gamma divided by gamma minus 1, and this is our expression 3. Okay, now look at equation, that is expression number 1 and expression number 3. Left hand side will be the same pressure. So P is proportional to T cube and P is proportional to T power gamma divided by gamma minus 1. I am going to equate the right hand sides, okay. So comparing 1 and 3, I can write now T raised to the power gamma divided by gamma minus 1 is equal to T cube, or equating the powers gamma divided by gamma minus 1 is equal to what? 3. So gamma is equal to 3 into gamma minus 1. So this is equal to 3 gamma minus 3. So this minus 3 is shifted to the left hand side. It becomes plus 3. This is equal to 3 gamma minus gamma. So 2 gamma is equal to 3, is it not that? So 2 gamma is equal to 3, therefore gamma must be equal to what? 3 by 2. So we have got the answer for Cp by Cv equal to gamma, and that is equal to what? 3 by 2. So which of the options is correct? Now see, option C is 3 by 2, is it not that? Therefore option C must be the correct answer. Now children, this problem is based on the adiabatic process. Okay, so the equation of state for the adiabatic process we have to remember, which relates temperature and pressure, and that has to be compared with the given equation, the pressure temperature relationship. And here whenever the powers of temperature and pressure are adjusted, no, you must have the knowledge of mathematics also. I hope you must have understood this fine.